Welcome to a lesson with Dr. Powell. Let's take a look at the idea of a derivative and what that is. We've been talking about the slope of a tangent line, and we were taking a limit of slopes that we would get just by taking 2 points on the line, pretending that was the function, and just finding the slope of that, and then taking a limit as h went to 0, as the run went to 0. So, for instance, suppose we had f of x equals negative x squared. Then, if this point right here is at x equals -1, then what we could think of is okay, this point right here would be f of -1, because that's the y value right here for this particular x value. And this y value would be, if we go over h, this would be f of -1 plus h. And then we could think the slope is rise over run. So the rise, the difference of y values, over the run. And then we take a limit. Then if we wanted this to be general, so we didn't want to just pick x equals -1, but just let x be arbitrary, we could just let that be x. Let this be f of x, and let this right here be f of x plus h. Okay, and then we go ahead and we compute this limit, which is the slope. All right, and we can do this by putting x plus h in for x here, and negative x squared. So we get negative x plus h quantity squared minus a negative x squared, and we put that all over h, and we simplify here, multiplying that out, negative x squared plus 2xh plus h squared, and then we have plus x squared all over h, and see the x, so the negative distributes to there and to there, making all of these negatives right here, so that would cancel out with that. And in taking a limit now, we can factor h out of the top, so 2x plus h, in fact I factored out a negative h out of the top, and taking a limit now, this part right here limits to 1, so we end up getting, and as this part goes to 0, as h goes to 0, so this whole thing limits to -2x. Now what does this mean? This means that at the x, so at an x coordinate, x, we know what the slope is. The slope will be -2 times the x coordinate. That's the slope. That's kind of neat. The slope is like a function itself, the slope of the tangent line. This is a tangent line slope. The tangent line slope is a function of x. So given a value of x, I can tell you exactly what the slope is, -2x. This function we call the derivative function of f of x equals -x squared. It has some notations. So we say f prime of x is equal to -2x. See how this prime is kind of like a line, kind of like a slope, kind of like a tangent line, maybe, just for remembering it, maybe. So this is called the derivative function of f, and we notate it by f prime of x is equal to -2x. Another way of notating it is as follows. On the function itself, we usually use this triangle or this delta symbol to refer to change of x, change of y. Now, on the tangent line, though, we use different symbols. On the tangent line, we use dy, so we use an English d or a Latin d, dy and a dx here, it's dy and dx. So when we're talking about slope of the tangent line, we can simply write dy over dx, because that's the slope of the tangent line. Well, dy over dx can loosely be thought of as the derivative here. And so this is an alternate notation. Keep in mind that this is changing per value of x, and sometimes this notation can be cumbersome because it's hard to plug things into this notation for different x values. However, this notation is very nice for plugging in things. You can still use this notation when you plug in. It just is as follows. It's a little bit more clunky. X equals -1. If we want to find the slope at -1, compare that to this notation. F prime of -1, less clunky. However, there are some nice uses for this, and we'll be discussing these in another video. Nonetheless, we have this idea of a derivative function. And we actually can think of it as being a limit right here of rise over run, where x is arbitrary, and we actually get it. Thanks for watching.